my dear math lovers, welcome back to my channel. Today we are discussing the concept of limit in detail, the definition of a limit and the exercises from the section 1.3 of the chapter Limit and Continuity, the textbook Calculus and Analytic Geometry, Thomas and Finney, 9th edition. The precise definition of limit. In the previous video, we already discussed an informal definition of limit. Today we are going to discuss formal definition. Let f of x be defined on an open interval containing x0 except possibility at x0, possibly at x0 itself. We say that f of x approaches the limit L as x approaches x0 and write limit extend to x0 f of x is equal to L if for every epsilon greater than 0 there exists a corresponding number delta greater than 0 such that for all x 0 less than mod x minus x0 less than delta implies mod f of x minus L less than epsilon. That is, if we have a function f of x defined on an open interval containing x0 and that function f of x may or may not be defined at x0. To say limit extend to x0 f of x is equal to L, for any epsilon greater than 0, we should get a delta greater than 0 such that for all x satisfying this condition, 0 less than mod x minus x0 less than delta implies mod f of x minus L less than epsilon. To understand the definition, we can have a rough sketch. Let y equal to f of x be a function, be some any function. To say limit extend to x0 f of x is equal to L. Here suppose that y equal to f of x is a function and this function has the limit L. Definition says for any epsilon greater than 0, for any epsilon greater than 0, for any epsilon, any small value of, the definition is for any epsilon greater than 0, we should find a delta greater than 0 satisfying 0 less for all x, 0 less than mod x minus x0 less than delta implies mod f of x minus L less than epsilon. Here in this graph, for any epsilon greater than 0, any small value of epsilon, for very small value of epsilon, we should get a delta. Let it be the epsilon distance from this point to this point. We should get a, let it be a, b, a delta greater than 0 which keeps this function within this interval. We should get a delta distance x0 plus delta, x0 minus delta. We should get a small delta keeping this function within this limit for any epsilon greater than 0. We will understand the concept more clear while doing the exercises. In the definition of limit, we need a delta positive. We need a positive delta for any given value of epsilon. The process of finding delta is very simple. We can explain it in 2 steps. Finding deltas algebraically for given epsilon. How to find a delta for a given f, L, x0 and a epsilon greater than 0 algebraically. If we have given a function f, the limit L and the point x0, also the positive epsilon, we have to find a delta satisfying the condition 0 less than, for all x 0 less than mod x minus x0 less than delta implies mod f of x minus L less than epsilon. First step, solve the inequality mod f of x minus L less than epsilon to find an open interval AB about x0 on which the inequality holds for all x not equal to x0. First, we have to solve the inequality mod of f of x minus L less than epsilon. Then we will get an interval AB containing x0. Next step, find a value delta greater than 0 that places the open interval x0 minus a delta, x0 plus delta centered at x0 inside the interval AB. Then we have to find a delta keeping this interval x0 minus delta, x0 plus delta within the interval AB. Then the inequality will hold automatically. The inequality mod f of x minus a less than epsilon will hold for all x0 equal to x0 and this delta interval. We can go to the exercises. Exercise. Centering intervals about a point. In exercise 1 to 6, sketch the interval AB on the x-axis with the point x0 inside. Then find a value of delta greater than 0 such that for all x 0 less than mod x minus x0 less than delta implies a less than x less than b. For each questions, we have to sketch the interval AB and also we have to find the value of delta. Positive delta satisfying the condition for all x 0 less than mod x minus x0 less than delta implies a less than x less than b. First question, a equal to 1, b equal to 7, x0 is equal to 5. We can make a rough sketch. Let it be x-axis, points 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. It will be the x-axis. We have to mark the interval AB. Here a is equal to 1, b equal to 7. So we have to mark the interval point 1 and 7. This is the interval A, B with the x0 is equal to 5 inside. Then we have to find a value of delta. To find delta greater than 0 such that for all x 0 less than mod x minus x0 less than delta implies a less than x less than b. We have to find a delta satisfying this condition. For that, take a less than x less than b. Here a is equal to 1 less than x less than b is equal to 7. Here the interval is 1, 7. Then we have to find a delta satisfying this one, x minus x0. So here x0 is equal to 5. Therefore x minus x0 is x minus 5. Here 7 minus 5. Here 1 minus 5. 1 minus 5 is minus 4. X minus 5 less than 7 minus 5 is 2. Look here. This point comes, let it be 0. Here 2, 4, minus 2, minus 4. Here we get the point minus 4, 2. X minus 5 lies in between these points. So we have to, delta is the interval lying inside this. So delta, we have to take the minimum distance here. Here distance from 0 to minus 4 is 4 and distance from 0 to 2 is 2. So minimum distance is 2. Delta is 2. This becomes mod x minus 5 less than 2. Implies delta is equal to 2. Next question. A equal to minus 7 by 2, b equal to minus 1 by 2, x0 is equal to minus 3. Minus 7 by 2 is minus 3.5 and minus 1 by 2 is minus 0.5. Now see, here the x-axis 0, minus 1, minus 2, minus 3, minus 4, etc. We have to mark a, b and x0. Mark the interval AB. A equal to minus 3.5. Here A and b equal to minus 1 by 2. Here minus 1 by 2. B. This is AB with the x naught is equal to minus 3 here, x naught. Next we have to find positive delta satisfying 0 less than mod x minus x naught less than delta implies a less than x less than b. A less than x less than b. Here a equal to minus 7 by 2. Minus 7 by 2 less than x less than b equal to minus 1 by 2. Now minus 7 by 2 minus x naught is minus 3. Minus 3 less than x minus minus 3 less than minus 1 by 2 minus 3. This is 6 minus 7 minus 1 by 2 less than x plus 3 less than 5 by 2 implies mod x plus 3 is less than 1 by 2. So we get a value satisfying a positive delta satisfying the above condition. So take delta equal to 1 by 2. Then the equation will hold. Next question, a equal to 4 by 9, b equal to 4 by 7 and x naught is equal to 1 by 2. 4 by 9 is 0.444 etc. and 4 by 7 is 0.571 etc. And the rough sketches here 0, 1, 2 etc. Here we have 0.5. This is x naught and a is 0.444 somewhere here and b is 0.571 somewhere here. A, b. Now to find delta, here a less than x less than b is a equal to 4 by 9 less than x less than 4 by 7. Now x naught is 1 by 2. So 4 by 9 minus 1 by 2 less than x minus 1 by 2 less than 4 by 7 minus 1 by 2, which is minus 1 by 18 less than x minus 1 by 2 less than 1 by 14. Therefore mod x minus 1 by 2 is less than 1 by 18. Therefore delta equal to 1 by 18. Next question, finding deltas graphically. In exercise 7 to 14, use the graphs to find delta greater than 0 such that for all x 0 less than mod x minus x naught less than delta implies mod f of x minus L less than epsilon. Question number 7, here a rough sketch is given with some values. A graph y equal to 2x minus 4 with some points. F of x here is 2x minus 4, x naught is 5, L is 6 and epsilon is 0.2. We have to find delta. Epsilon is the minimum distance here from 6 to the point A or B. The minimum distance we have to take here. The distance is same 0.2. So epsilon is 0.2. Similarly delta is the minimum distance from x naught. Here the distance is 0.1. Therefore clearly delta is equal to 0.1. Next question, a graph is given. Here y or f of x is equal to root x with x naught equal to 1, L equal to 1 and epsilon is equal to 1 by 4. We have to find delta. Delta here is the minimum distance from here. Here the distance from 9 by 16 to 1 is 16 by 16. Therefore here the distance is 9 minus 16. That is minus 7. So the distance is positive. So 7 by 16. And here the distance is 16 by 16 minus 25 by 16. The distance is 9 by 16. The smallest here is 7 by 16. Therefore delta equal to 7 by 16. Next question. Here f of x is equal to x square, x naught is equal to 2, L is equal to 4 and epsilon is equal to 1. To find delta, we have to check which is the minimum distance, root 5 minus 2 or root 3 minus 2, modulus of root 3 minus 2 or modulus of root 5 minus 2. Here root 3 is equal to 1.73 etc. and root 5 is equal to 2.236 etc. Now 2 minus root 3 is 2 minus 1.73, almost around 0.27 something, and root 5 minus 2 is 0.236 something approximately. Therefore minimum distance is root 5 minus 2. Therefore delta is equal to root 5 minus 2. Next question, f of x is equal to 2 by root of minus x. X naught is equal to minus 1 and L is equal to 2. Epsilon is equal to 0.5. We have to find delta. To find delta, we have to find which distance, this one or this one, which is minimum. We can see minus 1 minus 16 by 9 is equal to, minus 1 is just 9 by 9. Minus 9 by 9 plus 16 by 9 equal to 16 minus 9 is 7 by 9, and this distance is minus 16 by 25 minus 1. Instead of minus 1 we can write minus 25 by 25. Minus 16 by 25 plus 25 by 25 is equal to 25 minus 16 is 9 by 25. Now 7 by 9 is approximately 0.77 etc. and 9 by 25 is equal to 0.36. So smallest value is this one. Therefore delta is equal to 9 by 25 is equal to 0.36. We discussed how to find deltas graphically. In the next video we can discuss how to find deltas algebraically. So thank you for watching. If you find this video useful, please like, share and do subscribe to my channel. Thank you.